Hello and welcome to the first video of Chapter 7 of James Stewart's calculus textbook, at least the version that I'm using. It's Chapter 7, and this is a chapter on inverse functions. And so in this video, we want to ask, what is an inverse function? What is an inverse function, you ask? I hear you. You're asking it. Well, in general, okay, let's say we have a function of for any function of x, it spits out y. So we put in x, bing, y comes out. So the inverse of this is going to be basically that if I were to put the y in the inverse function, it would spit out x. So it's kind of like if you've got a machine, you put this in here, this comes out here. So the function is you put x in here, y comes out here. Well, basically, the inverse function is you put y in here and x comes out here. So it's like it goes in, it's the reverse or the inverse of the first one. Let's give you an example. So let's say we have a function y equals x cubed. So basically, the inverse is going to be a situation where x equals y cubed. I've just switched things around. I've made the domain of the one has become the range of the other, and the range of the other has become the domain of this one. Now, if I solve for y, then basically this is basically in the inverse function of it. So we don't usually write x equals whatever, we write y equals. And so the inverse function of y equals x cubed is y equals the cube root of x. Again, how did I arrive at that? I switched the variables and solved for y. Okay, so that's the inverse function. Now, this only works for what are called one-to-one function. A one-to-one function is a function where if you put, for every number you put in, you're only going to get one number out. So for example, when I was first making this slide, I thought about starting with y equals x squared, but x squared doesn't work because there's both the positive and the negative, right? It's plus or minus the square root of x squared. And so y equals x squared is not a one-to-one function. So a one-to-one function is a function that never has the same value twice. Okay, and so f of x1 will never equal f of x2 if those are two different numbers, right? I mean, if x1 equals x2, then of course it's going to equal, but if x1 and x2 are different numbers, the function, so when you put x1 into it, you're never going to get the same value as when you put x2 into it. That's a one-to-one function. So you might remember the vertical line text. The vertical line test decided whether something was a function. The horizontal line test determines whether something is a one-to-one function. So no horizontal line will intersect in a one-to-one function. A horizontal line will never intersect the graph more than once. Okay, so if you do a graph of y equals x squared, it's going to be a parabola, and a horizontal line is going to hit the graph more than once. But the x cubed one is not that way. It passes the horizontal line test. Okay, so here's the official definition of an inverse function. If f is a one-to-one function with a domain A, that's the stuff you're putting into the machine, and range B, that's the stuff coming out of the machine, then the inverse function, f inverse, so this is written f with a superscript of -1. It is not the function to the -1 power. Stewart mentions that several times. This is read f inverse. It's not 1 over f, for example. This is just the way of writing f inverse. This is just the way of writing the inverse function. So don't confuse that for a power. It is not a power. It's just a way of writing f inverse. Okay. So if f is a one-to-one function with domain A and range B, then the inverse function f inverse has domain B and range A. See, we flipped the domain and the range, and it basically says what I said at the beginning. F inverse of y equals x if and only if f of x equals y for any y in the domain B. Okay, so again, what have we done? We've switched where the variables go. and that is the inverse function. So this is, again, stuff I've already said. Why am I saying it again? Because the PowerPoint has it, so I'm obligated to tell what the PowerPoint says. So the domain of F inverse is the range of F, and the range of F inverse is the domain of F. And again, we're just saying that we've switched the range and domain. That's all that we're saying there. By the way, if you want to cancel out the equation, if you take the inverse function of a function, you're left with x. It's like, have you ever done one of those things where you put the strings together and you put your hand in and the person pulls it and the hand is free? You know, that's what's happening here. If you do the F inverse of the function, you're just left with x. Or vice versa. If you take a function, if you put x into the function of the inverse function, if you put the inverse function into the function, you're just left with x. So these are the cancellation equations. Okay, the graph, here's something new, rather than me simply saying the same thing over and over again. The graph of F inverse of x is a reflection of f of x about the diagonal, y equals x. And so if you have something up here, then the inverse is going to be the reflection of it in the watery pool of y equals x. So the graph of F inverse is a reflection of the original function about the diagonal y equals x. Okay, some calculus comments before we stop this stammering. If f is a one-to-one continuous function on some interval, then its inverse function is also continuous. Okay, so if the function is continuous, then it follows naturally that the f inverse, the inverse function, is also going to be continuous. Okay, now it's also interesting to note that for inverse functions, so for inverse functions, the derivative of the function, let me pause to get my apologies. My calculus spidey sense was going off. I had this flipped. So now returning to the correct nomenclature, that the derivative of the inverse, notice how dx dy, not dy dx. So the derivative of the inverse is 1 over the derivative of the original function. This is, so basically the slope of a inverse function is the multiplicative inverse of the slope of the original function. So they would equal 1 if you multiply them by each other. This is because, remember, their reflection in across the x equals y line. And so the slope of the function is going to be 1 over the slope of the inverse function. Does that make sense? So dx dy is 1 over dy dx. I found this way of putting it is easier to see it than this schlock, which is the way it's usually put. Why does it have to be put in a complicated way? But basically, the derivative of the inverse function is 1 over the derivative of the function. So there you have it. Again, this is much easier to see. The derivative of the inverse is 1 over the derivative of the original function, or their slopes are multiplicative inverses, meaning that if you multiply them by each other, they equal 1. Well, this has been an introduction to inverse functions.